In the last video, we learned about the null space of a matrix A. So it's the set of vectors x such that AX equals 0. In this video, I want to show you how one can use the null space to determine the general system of an underdetermined, the general solution of an underdetermined system of equations. So we're going to consider the equation AX equals B, where there's fewer equations than unknowns. Okay, that's called underdetermined system. And what does that mean in terms of the matrix A? So the number of equations are the number of rows of A. The number of unknowns is the number of columns of A. So that means the number of rows is less than the number of columns. Okay? So we want to determine the general solution in this case. There will not be a unique solution, but there'll be a continuous range of solutions. So how do we do that? Well, let U then be a general vector in the null space of A. Okay? So the general vector may, the null space of A may have, 2 or 3 vectors as basis vectors. So the general vector will be a linear combination of the basis vectors of the null space of A. Then we're going to let V be any vector that solves the equation, solves AX equals B. Okay? And the trick here is that the general solution to the equation AX equals B will be a sum of U and V. So X equals U plus V will be the general solution to AX equals B, right? I can show you that, right? So A times X, right, is equal to A times U plus V. And that's equal to A times U plus A times V. So U is in the null space of A. So A times U equals 0. And A times V, V is a vector that solves AX equals B. So A times V is equal to B. So this is B. Okay, so this X of the null space plus the any vector that solves AX equals B then gives us AX equals B. And U is a general vector in the null space. So because the null space could have a large dimension, then this solution then will have a big range of possible solutions because we have multiple basis. We have may have a large number of basis vectors for U. Okay, so I think we should work an example. Let me give you a system of an underdetermined system of equations. So we'll work with 2x1 plus 2x2 plus x3 equal to 0. And the second equation will be 2x1 minus 2x2 minus x3 equal to 1. Okay, so we have 2 equations here, and we have 3 unknowns. Okay, so this is underdetermined. And I want to find then the general solution of this system. So we can write the augmented matrix for this system. So we have the coefficients 2, 2, 1, and 0 for the first equation, right? We're putting the right-hand side into this matrix. For the second equation, we have 2, minus 2, minus 1, and 1. Now we can do Gaussian elimination on this augmented matrix. We're going to want to find the null space, so we should bring this matrix to reduced row echelon form. You can do the arithmetic required to do that. I did that already, so let me just write down the answer. We're going to have 1, 0, 0, 1 quarter. And we have 0, 1, 1 half, and minus 1 quarter. Okay, so that's the reduced row echelon form of this matrix. Okay, so the first step here of finding the general solution of these two equations, the first step will be to find the null space of A. Okay? We find the null space of A by forgetting about this right-hand side. So the last column here is comes from the right-hand side. So for the null space, the right-hand side is 0. So we're just considering the equation x1, right? Reading x1 times x2 times x3 from this 2 by 3 matrix. We have x1 equals 0. And then we have x2 plus 1 half x3 equals 0. So x2 equals minus 1 half x3. Okay. So the null space of A has the following basis. So the basis we can construct from x1 equals 0. X2 is equal to minus 1 half x3. And x3 is x3. So x3 is the free variable. So this is equal to x3 times 0 minus 1 half 1. So this is the basis then. This vector here will be the basis for the null space. Okay? The null space is just spanned by one vector. That's the U. Now we need to find the V. So we need to find any vector which satisfies this equation. So we have two equations here. We have the second step then is to find what I'm going to call this vector that satisfies AX equals B, the particular solution. So find, here we called it V, which I'm going to call the particular solution. Okay, because that's the word I use in differential equations for a similar type of problem. So how do we find V? We look at this reduced row echelon form. So this is now the full equation with the last column being the right-hand side. So we get x1 is equal to 1 quarter. And then we get x2 plus 1 half x3 equals minus 1 quarter. Okay? Here, x3 is the free variable, right? So in this system of equations, it doesn't give us a unique solution, right? That's the whole point of this system, that we do not have a unique solution. This x3 is what we call the free variable here. We can set x3 to anything we want. So here, the easiest thing is just to set x3 equal to 0. Okay? You don't necessarily have to do that, but it's the simplest thing to do. And then we get as our solution here, x1 equals 1/4 and x2 equals -1/4. So putting it all together, we can find the general solution here. So let me write it down at the bottom here. We have x1, x2, x3. Equals to the null space solution, which is this one here. So it's a free constant. x3 here is a free constant in the null space solution, this x3. So it's just some constant times this vector. So the general solution is some free constant. So I can call that a times this vector, 0, -1/2, 1. Plus the particular solution, which comes from here, which is x1 equals 1/4. x2, taking x3 equal to 0, x2 equals -1/4. And x3 equal to 0. Okay, that's the general solution to this underdetermined system of equations. So it's a family of solutions. A can take any value because this first vector is spanning the null space. So when you take a times x, this first vector will be 0. So a can take any value. And then when you take a times this second vector, you get the right-hand side b, which will be 0, 1. Okay? You can check that this is a solution to this system of equations. It's the general solution because it's a family of solutions where a can take any value. So let me summarize. I'm showing you one of the applications of the null space of a matrix. If you have a system of underdetermined system of equations, so you have fewer equations than unknowns, and you're tasked with finding the general solution, then first you have to find the basis vectors for the null space. And then a span of those basis vectors will always give you 0 when you substitute in for x. And then on top of that, you have to add one solution, which I call the particular solution, that will give you the right-hand side b. And that's what I did for this example. I hope you will do the exercise. It may help you to clarify this lecture. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.